All right, so you guys send over this set of guidelines on flame detector installation and maintenance, and wow, talk about a deep dive. This stuff is serious business.
You can say that again, that this isn't exactly light reading. It's about as critical as it gets when it comes to preventing, fiery disasters.
No kidding. It's not every day we get to delve into such a specific area of, well, safety, I guess.
Right. And what's fascinating about this is how much goes on behind the scenes, the planning, the execution. It's all about keeping those systems running smoothly.
Well, and speaking of planning, that's the first thing that jumped out at me in this document, the need for something called a HAZOP study. Is this just me, or does that sound kind of intimidating? What even can CZOP study?
It's funny you should say intimidating because a lot of people have that reaction. HAZOP stands for Hazard and Operability Study, and it sounds way more complicated than it actually is. Basically, picture this. You get all the experts in a room, and you basically just try to think of everything that could possibly go wrong with the process.
So like a worst case scenario brainstorming session?
Exactly. What if the temperature spikes? What if there's a power outage? What if a sensor decides to take a vacation at the worst possible moment? It's all about uncovering those hidden vulnerabilities before they turn into, real world problems.
Okay, so being proactive rather than reactive. Got it. And in an environment with, flammable materials, that kind of foresight could be the difference between, a close call and a full-blown disaster.
100%.
So, okay,
Yeah.
you've done your HAZOP, you've identified all the potential hazards. What's next? You've got to make sure your detection system can actually catch those hazards, right?
You're way ahead of me. That's where this whole FGFD coverage mapping thing comes in. It's basically strategically placing those flaming gas detectors so that you've got, full coverage of the entire area, no blind spots.
So it's kind of like a, fire safety blueprint for your facility?
Exactly. And just like you wouldn't use the same blueprint to build, a tiny house and a skyscraper, FGFD coverage mapping isn't one size fits all. Different hazards, different layouts, it all needs to be tailored.
It makes sense when you put it like that. Now, one thing that really jumped out at me in this document was the emphasis on qualified installers. It's like they're saying, hey, this isn't your weekend DIY project.
You got that right. Imagine trying to, rewire your entire house after watching a 5-minute YouTube video. These systems are complex, man. Even a tiny mistake during installation can have some major consequences.
Okay, so no pressure on those installers then, right?
Yeah.
But seriously, what kind of things could go wrong? What are we talking about here?
Well, they talk about something as simple as vibration, and you might think, what's the big deal? But imagine a detector mounted on a shaky platform, near a big piece of machinery. That constant shaking can really mess things up.
Really? I never would have thought of that.
Yeah, it can cause false alarms, or even worse, it could prevent the detector from accurately sensing a real fire. And that's just one example.
So what? So like loose connections, bad grounding, incorrect power supply, all of that can really make a difference.
Oh yeah, all that stuff can basically make your fancy detection system about as useful as a screen door on a submarine when you need it most,
Yikes. Okay. So no cutting corners on the installation.
Definitely not.
All right. So we've got our expert installers. They've followed all the guidelines. The system's all set up and ready to go. We're good, right? Pop the champagne.
Not so fast. There's one more crucial step. Commissioning. Think of it like the final exam for your whole system.
The final exam. Okay, I like that. So it's not enough to just have things plugged in. You got to make sure they actually, do what they're supposed to do.
Exactly. It's about making sure everything's talking to each other, playing nicely together.
So kind of like making sure all the instruments in an orchestra are in tune. Otherwise, you just get a cacophony of noise instead of, beautiful music.
Perfect analogy. We're talking calibration, communication, making sure it all integrates with the other safety systems in place. It's got to be a well-oiled machine.
Okay, I'm picking up what you're putting down. A well-commissioned system equals a well-rehearsed orchestra. Everyone's got their part to play.
Couldn't have said it better myself. And of course, once you're all tuned up, got to make sure the orchestra can actually, handle the music. That's where the testing comes in.
And this document, they really emphasize testing, even mentioning, get this, a real fire test. A real fire test. Now, that's commitment.
Yeah, that's definitely not your average Tuesday afternoon. They do mention that it's not always feasible or safe, of course, but the point is you got to simulate those real-world conditions as closely as possible.
Right, make sure it can handle the heat, so to speak. So if a real fire test is out of the question, what are the alternatives?
Well, they talk about using test lamps, for example, to mimic different types of flames, different intensities. You got to make sure those detectors can spot a fire from a mile away, metaphorically speaking, of course.
Right, right. No actual fires from a mile away, hopefully.
Yeah.
Okay, so we've covered the installation, the commissioning, the testing. What else is there? Is that it? Are we good to go now?
Hold on, hold on. We're just getting started. All of that was just the setup. Now we got to talk about the long game, the operations and maintenance. This is where the rubber really meets the road, you know?
Okay, so it's not a set it and forget it kind of deal.
Definitely not. Think of it like buying a fancy new car.
Okay, I like where this is going.
You wouldn't just drive it off the lot and never, change the oil or check the tire pressure. Right. You got to take care of it if you want it to last.
All right, that's a car analogy I can get behind. So, regular tune-ups for our flame detection system. What does that actually look like?
So we're talking regular inspections. Like, are there any cobwebs building up on those detectors? Is the lens clean? You'd be surprised how much dust can mess with their sensitivity.
Interesting. So it's the little things, the seemingly insignificant stuff that can make a big difference.
Absolutely. And then you've got your functional tests. Are the detectors still doing their thing, responding to stimuli? And of course, you got to document everything, every inspection, every test, every little adjustment you make.
So if something does go wrong, you can go back, retrace your steps, and hopefully prevent it from happening again.
You got it. It's all about being proactive, having well-trained personnel who know the system inside and out. They're your first line of defense.
Speaking of well-trained personnel, the document does have a whole section on training recommendations. What kind of stuff are we talking about here?
It goes beyond just, knowing which buttons to press. They really emphasize the importance of understanding the why behind the what. Why are we doing this inspection? Why is this safety protocol in place? You got to understand the reasons behind the rules.
Makes sense. And that understanding, that's what allows you to troubleshoot problems, adapt to new situations, that kind of thing.
Exactly. And speaking of understanding, we got to talk about hazard area classifications. This is where things can get a little, well, let's just say it's not the most exciting topic in the world, but it's important.
Yeah, those classifications, the class division, the zone systems, they always seemed a little bit like a foreign language to me. Not gonna lie.
Tell me about it. It's a lot of jargon, but it's actually pretty straightforward once you get the hang of it. Basically, it's all about categorizing different areas based on how much risk is involved, how likely are flammable materials to ignite in that particular spot.
So like a class 1 division 1 area would be a much higher risk than, say, a class 2 division 2.
Now you're speaking my language. Class 9 is usually flammable gases or vapors, whereas Class 2 is all about those combustible dusts. And yeah, Division 1 means a higher probability of, well, basically an explosion hazard.
Okay, starting to make sense now. And then there's the zone system, right? Which is kind of similar but also different.
Yeah, the zone system is more common internationally. It's the same basic idea, just a different way of slicing and dicing the risk levels.
Got it. Different systems, same goal, keeping everyone and everything safe.
Exactly. And, it's pretty amazing when you think about it. All this complexity, all this planning, all these regulations, it's all in the name of safety. It really makes you appreciate the people who work in this field.
It really does. I mean, it's a whole other world, a world of, potential hazards and meticulous precautions. It's pretty remarkable. It really is. And you know what else struck me about this document? It's like they threw in every possible curveball imaginable. Extreme temperatures, corrosive environments, electromagnetic interference, you name it.
Right. It's like a survival guide for flame detection systems. But hey, it's all about being prepared, right?
Absolutely. So let's say we're dealing with an Arctic environment, for example. What kind of challenges are we talking about there?
Well, you've got the obvious ones, like freezing temperatures and snow and ice. But you also got to think about things like permafrost. You might not think frozen ground would be a big deal, but it can actually mess with your grounding systems.
Really? Permafrost can affect grounding. How does that even work?
Well, it all comes down to conductivity. Permafrost doesn't conduct electricity as well as, regular unfrozen ground. And when you're dealing with sensitive electrical equipment like flame detectors, that can be a real problem.
Huh. The things you learn. It's like a chain reaction, isn't it? One seemingly small thing can have a ripple effect on the entire system.
Exactly. And that's why you got to approach safety from a holistic perspective. You can't just focus on one piece of the puzzle. You got to look at the big picture, how everything interacts.
It's all connected. Well, I've got to say, this deep dive has been a real eye-opener. I had no idea there was so much to know about flame detection and operational safety.
Right. It's a whole world behind the scenes, a world of, incredible technology and dedicated people working tirelessly to keep everyone safe.
It's pretty impressive when you think about it. So as we wrap up this deep dive, what's the one thing you really want our listeners to take away from all of this?
That's a good question. I think the biggest takeaway here is that safety isn't just about, following rules or installing the latest and greatest equipment. It's about cultivating a culture of safety.
A culture of safety. I like that. So it's like a mindset, a way of approaching everything you do with that awareness, that responsibility.
Exactly. It's about asking questions, thinking critically, never getting complacent. And that's something that goes way beyond just flame detection. No matter what field you're in, that mindset is invaluable.
That's a great point. So it's about always learning, always striving to improve, never settling for good enough.
100%. At the end of the day, it's all about protecting people, right? Protecting lives, protecting assets, protecting the environment. And that's something we can all get behind.
Couldn't have said it better myself. Well, thanks for joining us on this deep dive into the fascinating and surprisingly complex world of flame detection and operational safety. It's always a pleasure picking your brain.
The pleasure was all mine. Really enjoyed it.
And to you, our listeners, thank you for joining us on this journey of discovery. Until next time, keep those brains curious and those questions coming.